Section 1.2 is going to focus on linear inequalities. Alright, when we go to solve linear inequalities, there's one property that we need to review, and it's called the multiplicative property of inequality. What that means is anytime you multiply or divide by a negative, you need to remember to switch the inequality symbol. So if your inequality was less than or equal to, it switches to become greater than or equal to. And we're going to see this in the first example. We want to solve this, graph it, and then write it in interval notation. So we have negative 2/3 x plus 1/2 is less than or equal to 5/6. Well, the first thing I would do is I would get rid of fractions. So to get rid of a fraction, you multiply by the common denominator. We have a 3, a 2, and a 6. If I multiply every term by 6, I will not have to worry about my denominators. If I take, so now I'm doing that. I do 6 times negative 2 is negative 12. Divided by 3, I have negative 4x. 1/2 times 6 is 3, less than or equal to, and whenever I multiply by 6, but I'm dividing by 6 in the same step, well, those undo each other. You're left with 1 times 5, which is just 5. This looks like a much easier inequality to now solve. So we go ahead and we do that. I bring my 3 over. And now I need to divide both sides by negative 4. But be careful, I'm dividing by a negative. So whenever I divide or multiply by a negative, I need to make sure I switch my inequality symbol. So it's now going to become x is greater than or equal to negative 1/2. Alright, so we've now solved it. Let's go ahead and graph it. Here's my number line. I always like to put 0 in. Here's negative 1, so negative 1/2 is right in here. Now it can equal negative 1/2, and it also needs to be greater than. So to show that, I'm going to use a bracket. Bracket means that it can equal. Anytime you use brackets, then you must have the symbols less than or equal to or greater than or equal to. If they're not equal, then you'd use parentheses. So that would just be less than or greater than. Okay? So we have everything that is above negative 1/2 or equal to negative 1/2 can be as part of a solution. So I've graphed it. Now what that looks like then in interval notation is I start at negative 1/2 up to infinity. And since infinity is not a real number, you always use parentheses around infinity. Okay, when you go to solve compound inequalities is when it deals with more than one inequality. And you could have two cases there. They may be unions or intersections. If you have a union, it's a set of all numbers that are in either set, A or B. An intersection is where the sets overlap. So it has to be in A and it must be in B as well. So to start, we're going to practice this. We have two sets, A and we have set B. We want to find AUB, which is the union. This is a symbol for union. And if you see the N symbol, it's your intersection. So union wants where the solutions are common to this set or they're in this set. Intersection wants the solutions that are in both sets. Has to be in A and B. Alright, so let's start with this. I want A union B. So tell me those numbers that are in set A or they're in set B. Well, that's going to include all of the elements. Negative 2, negative 1, 0, 1, 2, 3, 4, 5. If you're doing unions, you want to find all possible answers. So it's going to be the answers that are in A and also the answers that are in B. But you only need to write each answer one time. So now let's do A intersection B. Now I just want to find the numbers that are common to both. And if you see here, 1 is in both sets, 2 is in both sets, and 3 is in both sets. Are there any other elements that are in both sets? It doesn't look like it. So then we're done. Alright, now let's go ahead and solve the next example. It's a compound inequality. We have 3x plus 5 is less than negative 1, and 3x plus 5 is greater than negative 13. So we want the solutions that are, or the numbers that are solutions to this one, and those numbers that are solutions to this. Alright, so this is actually a intersection problem. Anytime it specifically tells you and, it wants intersection. Alright, so I'm going to do the first inequality. 3x plus 5 is less than negative 1. And you solve that as if you would an equality. You subtract 5 from both sides. Divide by 3. Now I don't have to worry about switching my sign because I didn't multiply or divide by a negative. And I get x is less than negative 2. So for the next inequality, I'm going to go ahead and change my pen color. We have 3x plus 5 is greater than negative 13. Well, subtract 5 from both sides. I get negative 18. Divide everything by 3. X is greater than negative 6. So now I'm going to go ahead and graph both of these solutions on a number line. Alright, here's negative 2. I'm going to put in 0 just as a reference point. Here's negative 6. Now, it says x needs to be less than negative 2. Since it's not equal to negative 2, I want to make sure I use parentheses. And I want my parentheses to be open to where those values are less than negative 2. So I'm going to open it to the left. Okay, the next one, x needs to be greater than negative 6. Again, that's going to be parentheses because it's not greater than or equal to. And I want to open my parentheses to where the values that are larger than negative 6 are located. Alright, so intersection deals with where the solutions overlap. If you see here, the solutions are going to overlap between negative 6 and negative 2. Anywhere between those two values, those are going to be solutions that are common to both inequalities. So when I go to write my final answer in interval notation, it's going to be all those numbers that are between negative 6 and negative 2. Now they're not equal to negative 6 or negative 2, but they're the next ones after. Here's another compound inequality. And if you notice right away at the beginning, this one says OR. So this tells me, because it says OR, it's a union. I want all possible solutions then. All the solutions that are common for this inequality and the solutions for that inequality. Now let's go ahead and solve them both. I'm going to add 1 to both sides. And I have to divide everything by negative 3. Well, because I'm dividing by a negative, I need to make sure I switch my inequality from less than to greater than. So x is going to be greater than 1. Now the second one, 4x plus 3 is less than negative 6. I solved this one here. I'm dividing everything by positive 4, so I don't switch my signs. And I get negative 9/4. Or you could think of it as negative 2 1/4. Either way. Alright, now let's go ahead and graph on a number line. Because that number line is going to tell us how we write our answers in interval notation. Here's 1, here's 0, and I got negative 2 1/4 over here. Well, it says x needs to be greater than 1. It's not equal to, so I want to make sure I use parentheses and not brackets. And I want to open it to the values that are where the values that are larger than 1 are at. The next one, for x is less than negative 2 1/4, that's going to be open to the left. And it's parentheses as well. So my final answer in interval notation, it needs to include all the solutions that are in here, and then all those solutions that are in this one as well. So this one right here on the left, it goes down to negative infinity. So it's all values between negative infinity, negative 2 1/4. Or, I have to use my symbol for union here because it's an or, I could have answers that are at 1 all the way to positive infinity. Okay, the next example is also a compound inequality, except this one does not use the words and or, it just uses more than one inequality symbol. So when you see something like that, you want to think intersection. Okay? Alright, I'm going to solve for this middle part here. But those inequality symbols break it up into 3 parts. But I'm trying to solve for x. So the first thing I want to do is get rid of my negative 3. That means I'm going to multiply everything, or every part, by negative 3. And since we're multiplying by a negative, we need to make sure we switch our inequality symbols. Okay, the next example looks a little different than what we've done. But instead of using the words and or, we have more than one inequality symbol. So each of these inequalities is going to break it up into 3 parts. When you see something like this, you want to think it's an intersection. Alright, so I'm solving for my middle part here. I want to solve for x, which means I need to get rid of this negative 3 first. Well, what I do to one part, I have to do to all parts. So I'm going to multiply everything by negative 3. Well, those negative 3's then, negative 3 divided by negative 3 is 1. Now since I'm multiplying everything by negative 3, I need to make sure I switch my inequality symbols. So I have negative 3 is now less than 2x plus 5, which is less than or equal to 18. Okay, we flipped our inequality symbols because we're multiplying by negative value. Now, you see here we want to get rid of the 5. So I subtract everything by 5. I have negative 8 is less than 2x, less than or equal to 13. And now I want to get rid of that 2, so I'm going to divide every term by 2. I get negative 4 is less than x, which is less than or equal to 6.5. So we've now solved for our inequality, but we still need to write it in interval notation. And to do that, I want you to start by drawing it first on the number line. Here's our negative 4, there's 0, 6.5. Okay, so the first part says negative 4 is less than x. You can also read that as x is greater than negative 4. It's not equal to, it's just greater than. So I use parentheses, and then I draw a line to the right, because those are the values that are larger than negative 4. The next one, x is less than or equal to 6.5. This one is equal to, so I want to make sure I use a bracket. And I'm going to draw my arrow over those values that are less than 6.5. So you see here, it's an intersection. I want to find out where the solutions overlap. And if you notice, both of these lines cross between negative 4 and 6.5. So that's how I'm going to write my answer in interval notation. Parentheses on the negative 4.5, or negative 4, comma, 6.5, close bracket. Okay, we're going to switch gears here and talk about applications. And the first thing I want to focus on is domain. Domain refers to the set of allowable values. And we're going to see this in 2 examples. Example 6, determine the allowable values or the domain for this expression. You have 6 divided by x minus 2. Well, think about a fraction. What is the only number that you cannot divide by? That would be 0. So I need to make sure that x is not, that if I plug a value in for x, I do not get a result of 0. Which means I take my denominator and I find that value. Okay, x minus 2, if I set that equal to 0, that means x would have to be 2. So 2 minus 2 is 0. Everybody agrees, right? I don't want this answer then, because if I put in 2 for x, then I would be dividing by 0. So we say that x is a set of all numbers except 2. X cannot equal 2. Okay, this next example also deals with domain, except now I have my answer, or now I want to find the domain of a radical function. So I have the square root of x plus 3. Well, you can take the square root of any positive number and 0, but you cannot take the square root of negative values because those would result in imaginary numbers. So what you do here when you're finding the domain of a radical is you take the value underneath the radical, remember that's your radicand, and you set it greater than or equal to 0, because this value right here can equal 0, but it could also be larger than 0. And you just solve it for x. So as long as x is greater than or equal to negative 3, all of those solutions for x will work. And you can just leave your answer in that form. Alright, last example. Justin earned scores of 78, 72, and 86 on the first 3 out of 4 exams. What must he earn on the 4th exam to have an average of at least 80? Alright, it says at least, which means he can earn an 80, but he could also earn 85, he could also earn a 90. So that tells me that I want to use the inequality of greater than or equal to. Well, the question deals with average. So hopefully you remember how to find average. We're going to add up all the scores that he has. But he also wants to include the score for his 4th exam, which he has not taken. So to represent that, we just include an x. So when you find average, you add up all of those that you have, divided by the number that you have. Alright, and we want to set this greater than or equal to 80. And now I just solve this inequality and I'm done. Alright, we got to get rid of that 4, so we're going to multiply both sides by 4. And at the same time I do that, I'm going to add up these first 3. So that's going to give me 236 plus x must be greater than or equal to 320. I'll subtract 236. X is going to be larger than or equal to 84. So as long as he scores an 84 on his 4th exam, he will have an 80 in the class.